Good morning. My name is John McGowan, and I'm currently chair of the CETA Board of Directors, and I have the pleasure of chairing this mid-morning session. This is a time of deep change in the construction industry. We face the significant challenges of reducing the carbon footprint of construction, sustainability, including waste management, and constructing the now unavoidable defence or adaptation measures necessary to respond to the already possibly unreversible change in our climate. In Ireland, we face the additional challenge of building the infrastructure for a rising population from a deficit position. Our first keynote speaker is Professor Thomas Bock of Technical University, Munich, where he is chair for building realization and building robotics. He has concentrated his career on developing solutions for affordable housing and energy efficient renovation using robotics. These issues are among the major constructions currently facing us in Ireland, so I can assure Professor Bock of an attentive audience. Over to you, Thomas.
Okay, thanks, John, for introduction. So let me just get right into it. I'm going to talk a little bit about this, try to fit it to CETA, to the ideas of the gathering, and how to use construction robotics and how to implement it. And actually, I started already in the late 70s. Actually, I was the first student in University of Stuttgart and Karlsruhe. I studied both civil engineers and architecture. I was the first one who did his graduation thesis with computer. And in those days, it was a little bit difficult. I had to learn Fortran 77, and it took about actually 1.5 years. Normally, you're just allowed to do it in 6 months, but the professors somehow supported it. And so this was a kind of part listing and design. So it was alphanumerical and design drawings combined I wrote the program and the routines and the subroutine, kind of difficult. And but this got me into, and then I was interested in prefabrication. My father used to have a precast concrete factory in southern Germany, so I went all over the place with him. First, I could see it in the factory, and then I could see it on the construction site. And maybe you know the Munich Olympics in '72, and my father did actually all the precast concrete elements for the Olympics village where the sports people lived, and at the same time they had the BMW headquarters going on, and a very advanced construction by an Austrian architect, and they prefabricated the floors and they lifted them up. And after that time somehow slowed down the innovation in construction. So I went abroad a lot, and first, of course, in Europe, in France, where they had the famous Coignet factory, with ideas from Citroën. And then I went on to Texas. They had the interesting company in San Antonio by Zachary, and they made modules already with bathrooms. And then I found out about Japan, and Toyota also builds houses. And then I went on to Japan, and here you see one of the assembly lines of these of one of the companies, which is actually a chemical company that went into housing, and it became the housing daughter became bigger than the chemistry mother, which is a kind of interesting success story. And they make about over around 60,000 houses a year. So I was involved in Tokyo with them as well. I focused on the joining system, because if you find a very intelligent joining system, you develop one, you can assemble the buildings quite fast. So we brought it down to 4 hours for assembling a 150 square meter house, 2 floors, bathroom, kitchen, staircase already equipped. And then I thought, what does it help if you just got some nice prefabrication, offsite manufacturing, if you screw it up on the construction site? because most problems happen on the construction site. And it happened that at the same time, the Japanese started getting into on-site robotics. So this was kind of exciting, and I could join the team, some of the teams in Japanese companies that developed the first on-site robots. In the beginning, I couldn't handle the language. It was pretty difficult for me to learn this Japanese language because you couldn't relate to Latin. And in Europe, if you know Latin, you can somehow manage many languages. And but now I had to start from scratch like a newborn baby. So in the beginning, when I met the Japanese and when I discussed with them, I couldn't actually talk to them in the beginning. So I sketched and I showed them, this is some of my sketches. And I show it because actually it happened almost like I sketched it. So this was about 37 years ago, 38 years ago. And these are some of the robots also I was involved in. Small robots that are affordable, that can move around on the construction site. Of course, there are many more. I just give you a short overview. Actually, I publish a series with Cambridge University Press. It's called Contractual Robotics. We got about 300 listed in there. I'm working on a second edition, but first I have to do a 6th volume. So you can check up with Cambridge University Press. There will be something coming up maybe next year's another 6th volume, and later a second edition. So if you want to get into details, you can check also my homepage. I have a couple of videos, talks, and so on. And these robots are for concrete finishing, for exterior wall tiling and checking the tiles, so painting, interior finishing, assembly, welding of structures, and so on. We did recently a robot for renovation. Renovation will be a big challenge because in Europe, most of the building stock is already there. So only 2% new construction and actually renovation, upgrading of the buildings, especially for energy efficiency, is actually pretty expensive. So if you don't automate it, if you don't develop robots for renovation, it will be unaffordable, worse than the new construction because it's less structured. So first we did it manually. We prefabricated some facade, actually wooden facade, in order to be also ecological, and then in order to understand the process. And I also did the prefabrication, the robotic prefabrication of the wooden panels with some Spanish and French company. And then we proposed a joining system. I always start from the back end. You know, I do a sort of reverse engineering. I start at the final on-site assembly, or whatever you have to do on-site. I start at the end. It's like the final battle. And then I go backwards through all the process, on-site process, logistics, what you have to do in the factory and how you have to design it. I called it, in Tokyo, I called it robot-oriented design, which is also the title of my first Cambridge University Press book. And actually this robot-oriented design is very important, that you, from the beginning, you consider the final step on the construction side. And here we developed a joint which could adjust in various directions, axis to the inaccuracy of the existing building, because the new facade is very precise, it's prefabricated, but the building, which has been built a couple of decades ago, is not precise. So we have to compensate for this inaccuracy. And the robot, the end effector, has to adjust as well. So it's kind of complicated if you do a robotic renovation. Then we build the first prototype. The yellow cage, what you see here, actually is the core. It's another robotic unit for placing the joining system and then for attaching the facade. And this cage stuff we developed in my laboratory in Munich, which you can see behind me when we discuss. And so we did two. We had to improve. This was the first trial. in Spain, and then we had to improve it. And then after the second prototype, we could move on-site. We did it in the last 3 years. So last year we went on-site. And here you see the assembly of a panel. And then also it was successfully used on construction. Actually, we have a Euronews video on my homepage. You can see the Euronews. It was there last year. And also I was not only in Texas at a precast concrete factory in the 70s, but I also got a scholarship to study at IIT in Chicago. In those days, the tallest building was the Sears Tower. Now it's called Willis Tower. And I want to study under the professor who did it, Franz Lecan and Myron Goldsmith. So I got the scholarship in Chicago and to learn. Actually, it was those days the best school for high-rise, maybe in the world, not only in the States. And I did my thesis there on a multi-use high-rise building for the Chicago Loop. And it was those days the most slender building and the most efficient building concerning the steel consumption per square feet. And this was very helpful later because since I knew high-rise construction from those days, the best professors maybe in the world, I could use it while I went on to Tokyo. And then this was, you remember the vision I sketched. So I was involved also in the first automated high-rise construction system. I worked for this company in Japan. And it was also part of my doctorate. And you can find this stuff also in the Cambridge book and in the fourth volume, where I describe the automated construction sites. It took about 4 years to develop the prototype and then another 4 years to go on site. And we had about 20 robots moving simultaneously. You can see it here. The factory is installed on the upper left side. And then we got 20 of those yellow trolley robots inside the factory. So it's no tower crane. It's actually a new kinematic. And they move around. They can do 20 logistic and assembly tasks at the same time. And then it moves, the whole factory moves upward. It was a bank building in Nagoya. And so you can do the speedy construction. And here you see a part of my contribution. I was actually involved in the robotics and the building components and the design. And especially I focus again on the joining system. So the robot can join all the parts, the columns, the beams, the floor panels, the wall panels automatically. On the right side, I developed a snap-in connector because you really have to re-engineer the whole joining process and otherwise it doesn't work well. And here's some of the details. And now I'm allowed to show it. It was kind of critical while I did my doctor because the company asked me not to show it to anybody, not even to my doctor father, because even they kept it secretly within their own company. So I had a it was really interesting because I couldn't talk about my research within the company, outside the company, not even to my doctor father. And he somehow trusted me. And actually I prolonged my doctor. Normally you do a doctor in 3 years and artificially prolonged it to 5 years. I always blame the difficult language, but the reason was I wanted to be in Japan as long as they do this interesting robotics and on-site automation. So I artificially prolonged to 5 years my doctor in Tokyo. And here you see the details that I did. And I worked, you have to do both. You have to do the machine and you have to do the product. So the process and the product the development has to go hand in hand. And then also it was really interesting to think about the HVAC system, the MEPs, to join them because it's really difficult. I first tried to do it one by one, but then I found a detail from the shipbuilding industry and then they bundled it and then connect the whole bundle of pipes. And this was also used by Hong Kong Shanghai Bank, Norman Foster, who is also a pilot as me. I also got a commercial pilot license from Dallas, Texas. And we talk a lot about airplanes. And then we also get ideas a lot from other industries like Norman Foster also did. So The Japanese company Naka did the installation course with all the restrooms, with all the installation for the Hong Kong Shanghai Bank, designed by Norman Foster in 1984, 85, exactly the time I was in Japan. So I was with the Japanese company, went down to Hong Kong, could see how they first prefabricate all the course, the service course on the side. You see it hanging on the side of the Hong Kong Shanghai Bank. And they were shipped down to Hong Kong and then assembled on site. And this kind of system, a little bit better improved with some ideas from the shipbuilding, used it for the high-rise construction automation. Later, a Swedish company asked me to bring something to Sweden, and the Swedish have a long winter, so they want to build all year around. So I picked the system from Kajima, which is called Amurat. And so they first build the roof and then you push it up. So the Swedish can even build it all year round, even when it's snowing, because when you build first the roof, then everything is protected under it. It was not automated like in Japan. It was teleoperated, but still it was okay and pretty efficient. So Skanska could build all year around. Later, some problem happened in Holland because of the medical center. They needed some big tower, 135 meter. And in Holland, if you install a tower crane, you have to consider a 7 degrees falling angle. So this would have meant the tower crane cannot sway over other building. And so they have to stop the surgery room, for example, intervention room, which is not possible in one of the biggest medical centers in Netherlands. So I proposed them this kind of encapsulated construction site. It's like a vertical shipyard, also not automated, but teleoperated, but it was really high precision. The deviation of the tower was only 3 millimeter on 135 meters. And was maybe the best quality I've ever seen in Europe. The speed was faster, though the company didn't charge the medical center for the additional cost of the machinery, but they finished a couple of weeks earlier, so they could use it on another site. So was kind of interesting. This is just an example. The development goes on in Japan, Osaka, Yokohama. I'm still involved in these developments. And I want to show you also now going into reverse, the deconstruction. This is the system where you cut the ground floor and then you lower the whole building. So on the upper floors, while you're lowering the building, you can disassemble the interior, sort the interior into 30 different categories of containers. And once they reach the ground, you just pull the containers out. And then they have to cut. And it is difficult during the earthquake in Japan. So that you need an intermediate safety system for earthquake that could happen. Otherwise, the building might collapse because you cut the ground floor, actually. It's kind of risky. Here you see some sites in Tokyo. The lower one is actually across the Imperial Palace, very clean, no dust, no noise, 93% can be recycled. Another hotel deconstruction, this time from top down. And then, of course, for civil works, it's easier because you have continuous works in civil engineering, infrastructure, like caverns, underground cities might be built in the future, caisson, robotic caisson construction, huge LPG tank construction, all sorts of underground automated tunneling, prefabrication of the segments on top, and then bring it down alongside the tunnel. Everything is automated. The final assembly is also automated. This system was actually used for the Tokyo One Doro, which means from Kawasaki to Kisarazu across the Tokyo Bay. Kind of interesting. And then road construction is very good also for automation. Since I have a pilot license, used like an air traffic controller, control station, then automated construction machinery from Caterpillar or Komatsu. And then one construction manager, on-site manager, can overview maybe 5 or more machines and override the automation mode. And then we did road robot. This is also nice to automate it. And the Japanese have probably the most advanced because of many, many disasters. We have about 20 more typhoons, landslides, earthquakes, tsunamis. It's awful. I experienced it. And therefore they developed autonomous construction machine to remove all the dirt after landslide, floodings, volcano eruptions, and so on. First, a humanoid robot riding this excavator, then the autonomous construction machinery communicating each other because it's dangerous near the volcanoes. I experienced eruptions and also the damage, how to take care of all the damages, and the different examples where I've been actually. It looks nice on the slides, but it's really steep hill. You have to tie down sometimes the equipment, otherwise it would tumble down the hill. So it's not as easy as it looks. So maybe the future could be like this. I don't know the English word. I like the French word environ. I don't want to use environmental, but I think the French have a different meaning. This is maybe the future, combining infrastructure with building, and maybe we go into space as well as a next step. So this could be the future outlook for robotics in construction. You can check it in the Cambridge University Press book series. We're working on a sixth volume and later on a 2nd edition. And you can visit my homepage or at LinkedIn or ResearchGate, whatever you like. And you find also lots of videos, talks, TEDx talks or whatsoever there. Okay, I'm finished. Thank you.
Yeah, thanks very much, Thomas, for that talk. I think you've given us all an idea of what is actually possible, what has already happened, and the source to go to actually begin to continue, the source to go to, and so you can actually consider what in actual fact might be a good introductory step. But you're going to wait around, I think, Thomas, for some of the question and answers if we make it before our end deadline. Is that correct?
Yes, I try to hang on till 10:30, 11:30, or
yes.
What is your time? Yeah.
Yeah, I appreciate it very much. Okay, let's move on here. After a cautious start of digitization of construction, it has advanced at an accelerating pace in recent years, as delivery of productivity gains become more assured, should I say. But with every gain comes new risk. And our next speaker, May Winfield, who is the Global Director of Commercial, Legal and Digital Risk in Buro Happold, will offer guidance to us non-lawyers on some upcoming possible legal risks. Thank you.
Thanks, John. Do give me a shout if you can't see slides at any point. As you heard, I'm going to deal with some of the legal and contractual issues of BIM aimed very much at the non-lawyer community. My name is May Winfield. As you heard, I'm a specialist in BIM and construction technology, and I've been a construction lawyer probably for over 17 years now. For those of you interested in the area, I am very active on Twitter, and my Twitter handles there. Just very briefly, I'm from Buro Happold. If you haven't heard of us, you've probably heard of some of our projects, including Museum of the Future in Dubai. We're very technology focused. Because we're talking about BIM, it's worth mentioning the BOM, which is an industry-wide open source computational project, and we're aiming at enabling greater collaboration, overcoming interoperability issues, and a lot of our dashboards and a lot of our technologies have this as a foundation. But on the topic at hand, the Arcadis Global Construction Disputes Report said the average value of UK disputes in 2020 was $38.6 million US. It's a huge amount. And the two top causes of dispute, were parties failing to understand or comply with contractual obligations and owner-directed changes. And I'd argue the second one probably relates to failing to comply with contracts or contracts being very vague, because if it was obvious that the owner could make the change, how much you're going to be paid for it, you're not going to have a dispute. But what is a contract anyway? Well, I've been once told that a contract is written between two parties who don't trust each other. But I think that's a bit too cynical. I'd like to prefer to think that a contract's a fair allocation of risk and reward, or aiming at one that both parties are happy with. Another good definition is that a contract really a roadmap that shows where you want to go and how you're planning to get there, and that applies for both parties. It's important to bear in mind that not necessarily all the documentation you have as with your contract will be binding and enforceable, and it's worth getting professional advice saying which bits of this huge pack are actually my contract and which aren't incorporated. I've seen a lot of examples where the BIM technical documents don't actually form part of the contract and bear very little resemblance to the actual binding documents. And this matters because it's your binding contractual obligations and rights which you can enforce and which can be enforced against you. And it's worth bearing in mind as well, contract doesn't necessarily need to be in writing. And just because you have an agreement, it doesn't mean it's legally binding. Sounds very confusing. And that's why I do say it's worth getting professional advice if you're not sure. But in respect of BIM, it's worth checking that you have the EIR. So what does the employer want? The BEP. So how's the project team going to deliver it? The MIDP, Master Information Delivery Plan, again, more information, how the project team's going to deliver it, and a BIM protocol or information protocol. So a contract schedule, setting out all the more legal stuff, such as copyright and so forth. If you are missing one of these documents within your binding contractual documents, it's worth thinking, do you want to add it in? Because if it's not there, then no one has to comply with it. Sounds great, but I'll give you an example where that can go wrong. If you are, say, the contractor, you have a BEP, which isn't binding, your supply chain could wake up one day and say, well, actually, we're not going to comply with the BEP. We're just going to comply with our contractual obligations unless we have an additional fee, because the BEP is actually costing us more and costing us more time than we anticipated. And then you have a very difficult negotiation late in the day. The ISO 19650 is obviously very important. And this is a flowchart which I created with the author of ISO 19650 Part 2, Paul Shilcock, to try and explain how the ISO envisages contractual documents. And in particular, I'd draw your attention to the boxes in blue. And those are documents which are intended to be referred to or implied into your contract by the ISO. So there's a lot of danger in your contract simply saying you will comply with the ISO 19650, full stop. What does that actually mean? Not only will there be bits of the ISO which you maybe can't comply with, or your client doesn't want you to spend the money complying with because it's not relevant to the project. There's all these documents in blue which could potentially be, because of that sentence, be implied into your documents, into your binding obligations. So it's better to be clear as to where these are, or do you want to say in your document, actually, we agree we don't want to have these as part of the contract. Some of them are, they're very key to the ISO level of information need. For those of you who've encountered ISO before, you would have particularly encountered that sentence. The acceptance criteria, which is what does good look like? So the client has to say what do they expect to see in the deliverables, rather than saying at the end of the day, actually that doesn't quite look like what I expected. There's an ISO 19650 compliant information protocol, which you can get for free on the UK BIM framework website. And that is written for UK law. However, for other jurisdictions, I'd say a lawyer could pick that up and just amend it to be compliant with the local laws. It is meant to be, as much as possible, have as little legalese and legal terminology, although some is inevitable because of the nature of the document. There is just one page to fill in at the beginning, and it's called the information particulars, and it's really a schedule of who the parties are, some details about what the project's about, and lists all the documents that are relevant to the parties. And so there's a little box there where you say where those are located. And because it's a complete list and it's a template, some may not be relevant. There's a TIDP reference, which won't be relevant if you're the client and the lead contractor, and so you leave those blank. There may be some that don't exist yet, and you go back and fill those in. It's created very much to make it as easy as possible. You don't have to go through the document and fill in lots of empty spaces. I'd like to just clear up some confusion while I have the opportunity about the information protocol, because I know there's been various questions about the terminology we use in it. Now, the ISO uses the terminology appointing party, lead appointed party, and appointed party. Sounds confusing, but once you get used to it, it kind of makes sense. The appointing party being the client or the employer, the lead appointed party being the party appointed by the client or employer, so the lead contractor, the lead designer, and the appointed parties being all the rest of the supply chain, so everyone else. In the information protocol, we also needed some references to the parties who are entering into that agreement. So the person who's paying, the person who's giving the instructions, and the person who's being paid, the person who's actually carrying out the work. And the terminology we use are the appointer and appointee. And I know this sounds very similar to the ISO terminology. And we went back and forth over the year we wrote this, trying to find some terms which made sense. And these are the ones we came to because they were the most neutral. And I hope this chart gives you some explanation. So you're going to be either the one paying or the one being paid, and then you're going to be one of those green boxes. So that's just something to bear in mind when you pick up the information protocol. It is appointment agnostic. You can use it for multi-party, standard forms. There is various guidance on the UK BIM framework website if you are going to use it. And I'd recommend the UK BIM framework website as well, just for the various guidance it has. And the guidance includes templates. So even if you're not doing an ISO 19650 project, but just doing a BIM project generally, some of the templates, such as the TIDP template, can be quite helpful, particularly if you are trying to explain to other project team members who are quite new on their BIM journey what they need to do. I've put up there for you to look at later some resources when you're preparing contract documents. This is really for you to provide to your professional advisors to help you in preparing the contracts which are supportive for your BIM processes. But thinking about the legal risks, I would say if you are starting on a BIM project and you think, okay, I know there are various legal risks there. How do I know what they are? Start with a blank piece of paper or a blank Word document, and you first think, what are the processes that are going to be taking place? What are all the tasks and the duties that need to be done? What realistically could go wrong? And then who should bear all those realistic risks? Who should do each of those tasks? Where there are risks, who's best placed to mitigate them? And then how should they be mitigated? How should those tasks be carried out? What are the processes? It could be as simple as making sure records are kept, or the correct insurance is taken out. Or you may say, this person is the best person to work at how to mitigate that risk it's their problem. And this is something for you to openly discuss as early as possible. All the whilst bearing in mind the size of the risk. So there could be a really unlikely risk, but if it happens, it's going to be a huge loss. So you may want to mitigate it, even though it's quite unlikely. But then there could be very likely risks, things that are probably going to happen, but the losses will be very small. And so your mitigation steps will be proportional. And these are all things to think about. And hopefully at the end, you get to a list of things that you can then work out what to do about them. But for today, I'd like to focus on 3 particular issues: copyright, risk allocation, responsibility. The reason being, when you work out, look at your contract, or indeed look at your interaction with the other party, you'll often find it comes down to these 3 things. And I'll explain more. One being copyright. Obviously, digital data models, there's so much intellectual property behind it. When BIM first came about, copyright was the one issue that everyone had a lot of sensitivity about. And it's important to bear in mind, your lawyers probably won't understand the way a model is, what is contained in a model. So as you know, the model consists of a number of different elements. You'll have the objects in it, you'll have the data in it and the design, but you'll also have the data that could be produced from the model. And then you have the models themselves. And again, at a very early stage, it's worth sitting down and thinking, well, if the consultant or the contractor, which bits of these do I want to keep? Are there any templates, which are ones I use for every project? Is there any coding which is very unique to my organization? I need to carve those out. Do I not have copyright in the objects because I have a license from the manufacturer? So I must make sure I'm not saying I'm giving the copyright over to the client. And it's just, again, maybe listing all the different parts of the model and saying, well, these are the bits I want to keep, and these are the bits I'm happy to give up to the client. And just making sure your documents reflect that. And then thinking about risk allocation. What do I mean by risk allocation? Well, I mean, you're the one taking the risk. If something goes wrong, you are the one who will bear the loss of that, the liability for that, the financial consequences of the delay. And this can come in BIM in many forms. So thinking about software, you have version control issues, there's potential interoperability. If you're using different types of software, is it clear that there's steps to avoid those? What if there is, people are using different versions of a software and you can't open someone's model? Whose fault is that? Who's going to make sure that doesn't happen, or dealing with the delay if it does? There's the integrity of the data and making sure the data is checked. Who is checking the data and who's responsible if it doesn't get checked properly, if things get missed? And then the process generally. Who is bearing the risk of the process, the BIM process, not complying to the program, or the BIM models and the data not having the correct format, not following a certain standardized file naming and contents, which then leads to delay for everybody. And then looking at contractual responsibility. So in terms of contractual responsibility, I'm thinking about what it means, what you're actually doing in terms of your scope, what you're saying you're going to do. So where the problems that could come up, one of these is terminology. So if your scope just says do some BIM, or achieve net zero carbon, or achieve level 2 BIM, none of these things have any magical meaning unless you actually agree what it means. Equally, you can have a scope which could, when you look through the 5 pages of scope, there could be vague things that say you will attend sufficient meetings to achieve X. What does sufficient mean? It's very much a matter of opinion. Do you want it to be a bit clearer so you don't have that argument later on as to, well, I thought it meant 5 meetings or you thought it meant 10? Then lastly, deliverables. If you have a very vague set of deliverables, if it says, deliver me some 3D models, or I've seen things that say, deliver me some 5D models or clash-free models. Is that achievable, particularly when there's things like clash-free model requirement? And if it just simply says 3D models, what does that actually mean? What's going to be in the model? Does it need to be in a particular format? Again, if it's very vague, chances are you could have a disagreement later on because your client has a very particular idea what they want. And just having a sit down and recording what your discussion is in writing, because the person you're talking to now is probably not the same person you're talking to later. And just very finally, some final thoughts. If having done all that and you have your contract and it's all clear and there's a disagreement anyway, some things to think about and to talk to your professional advisors about, to talk internally to relevant people is, well, have a look who agreed to what. So going back to making sure your contract is clear. Are there any gaps or discrepancies? Is there scope for argument? Hopefully you avoided that by taking out all the other steps. And then work out what happened and who caused it. This is where records are so important. It's very easy to say, well, I remember this happened. But if you have an email, if you have proof of it, it's going to be much easier. You're going to save a lot of time and money in arguing about it. And just very finally, I've given a list of hopefully some useful links to cover more about some of the points I raised there. One of the ones I put at the end is a Building Smart white paper I was involved with about asset management at BIM. And there's not much about that topic at the moment. So hopefully you find that useful. Thank you very much.
Firstly, May, thank you for a very, very practical and honest talk. It's refreshing to hear anybody saying in the construction industry, asking whose fault other than our own is this, or sorry, should I say, whose fault other than the other party's fault is it? I find that very, very refreshing. Anyway, let's move on. The next speaker, Stephen Foley, is head of the bidding department of Collen Construction. Collen are a long-established Dublin firm who have successfully adopted many innovations down through the years of their life. There's a clue, by the way, to the longevity of the company in the scrolling of sponsor list at the bottom of the screen. Actually, today, Stephen is going to speak about the adoption of BIM in Collen Brothers. Thank you. Over to you, Stephen.
Thanks, John. Some fascinating presentations so far from Thomas and May. Thanks very much for those guys. We're delighted to be here today as platinum sponsor of the BIM gathering. And we're delighted to be involved with CETA and supporting CETA. It's been a very strange couple of years for all of us, so we're delighted to see the BIM gathering happening this year, albeit virtually. So I'll just get into this. So I'm going to start off with a brief background on myself and our business, and then we'll get into our very, very short case study on how our BIM adoption is impacting our different departments in our company. So I'm originally an architectural technologist myself, and I've most recently graduated with an MSc in Construction Informatics from TU Dublin, which was a course that was presented in conjunction with CETA. So I know the guys very well at this stage, and Alan as well very well. So look, we have a wide background, and it's proven to be very helpful to me in my understanding of the various processes that we are facing in relation to BIM. So just push on very quickly. So who are we? We're 210 plus years old, around a long time. Innovation is in our genes. We still have Collins in charge of the company and in ownership of the company. So we're around a long time, and we intend to be around for a lot longer. And as I said already, innovation has always been a main driver for our business. Where are we located? We're located primarily in Dublin. We also have an office in Galway. We are working in Frankfurt, and we're expanding in Frankfurt. We are working in Sweden and expanding in Sweden. We're also just about to move into Finland. A lot of our business is data centers, but we do pretty much build anything in Ireland, and in Europe, it's primarily data centers. One of our key, wins in respect to innovation is the team we have. It's an innovative team, proactive and always quick to embrace technology. So the leadership in Collen is a main driver for how much success we have had in adopting, new processes like the BIM process and all the associated processes. Two people of note there would be Ray Coote, who's the head of our BIM department, who has really driven this process, and Philip Tierney, who was a recent appointment last year, who's our Chief Information Officer, heading up all IT factors. But the entire team you see there are engaged in the ongoing improvements associated with the BIM adoption in the business. Growth-wise, we're at 350 full-time staff at the minute, and obviously we have a vast supply chain outside of that, so I won't go into too much detail there. Financial growth-wise, you can see that we're growing steadily and somewhat stably over the past few years, and we're going to top off about 450 million this year, which we're very happy about. Project-wise, there's a selection of some live projects. We have retail, we've data, we've medical, we have offices. Just a few more offices there. They're all Dublin, data centers in pharma Ireland, data centers Ireland and Europe, industrial jobs, airport projects, residential, medical, conservation work, fit out. We do a lot. We do it all. Primarily in Ireland, we would offer the full service, and in Europe we do specialize in data centers. We are an award-winning business. Our team and our processes have won awards on an ongoing basis: safety, construction manager of the year, and the like. Accreditation-wise, we carry all of these here, and we're very proud of our most recent one, which is ISO 27001 for information security, which has been a key achievement, and it's a requirement of many of our large data clients. We're currently working towards ISO 19650, the BIM accreditation. We're not quite there yet, but we're getting close. Again, we win a lot of awards. We work hard for them, and we feel it's important to recognize our team for their hard work. And our safety standards will be some of the highest in Ireland and indeed in Europe. So getting into the presentation proper, our BIM journey. So this is basically a very high level overview of how BIM has impacted our business and embedded itself into some of the main departments in the company over approximately a 5-year period. So as you can see there, the timeline is from 2016 to 2021, and we're going to look at the BIM department, the bid department, the estimating department, the marketing team, the planning department, operations, and IT, and how BIM has embedded itself into the business. So our BIM department was formed in 2016, initially with the key appointment of Ray Coote, who I mentioned earlier. It was really coming from market conditions. Our clients were expecting, this to be part of the offering, particularly our larger clients in the data world and the pharmaceutical world. We've grown year on year. We're about 10 people now, and we're still looking for more. Send CVs to me after a meeting if you're interested. But the BIM department it's key in supporting a number of different functions, but certainly in my end of the house, which is the bid department and proposal writing, we are locked at the hip. We work very, very closely with them in regards to pre-construction and operational project planning, particularly in communicating proposals made at the bid and operation stage. Massively important is animating visuals, logistical planning, that kind of stuff, spatial planning, as mentioned there. In regards to project preliminary planning and risk assessment, it's becoming more and more engaged in that process as well, because we actually are physically looking at spatial constraints and physical constraints on site by modeling them. So it really has become a massive part of that process. And in particular, again, in relation to communicating those risks to senior members of the team in a very short space of time to get decisions made, particularly in relation to bids and contract signing and that kind of stuff. Collen most recently employed a full-time VDC animator, which is again it's a massive win for us, and as we had to outsource that for many years, so huge win for us. In regards to what we are doing at the moment, we're seeing things like simulating how we're going to build stuff on site, obviously a major part of it, and then we always take little case studies as well in respects to maybe pre-assembly and how we might speed up the process. And again, a lot of this came from the data world, but indeed a lot of it came from the pharmaceutical world as well. So it is, a massive selling point for us, in respects to the pitch, the win of a bid, but it's also something that we're using operationally on an ongoing basis as well. So just push on. One of our, I suppose, key wins in recent years was this concept of a BIM cube on one of our large data projects in Dublin, where we presented essentially a cabin that you're seeing on the screen there now. And again, it was a brainchild of Ray Coote and one of our senior contracts managers, Willie Loughnane. And what we have here is a space where people can collaborate, interrogate models, look at clash detection in small breakaway groups outside of the larger format rooms. And it was a massive win for us on this project. And what it actually did allow us to do was to get the wider team, people that perhaps aren't as technically adept as others are, engaged in the BIM process, in particular in the clash detection process. So a huge win there, and something that we are very, very proud of, and we are using on a couple of sites at the moment. So what are we doing? We're integration of BIM into our accommodated environment was a challenge, and what we're having as an ongoing problem is that a number of clients have different CDEs, and they all have varying levels of compatibility or interaction with the BIM process. We are starting to utilize augmented reality. We have in the airport project that we're on at the moment in Dublin Airport. It's been very, very useful for selling the proposals and for communicating impacts of work on live environments. We're regularly integrating field data into models as either part of the contract deliverables from the client's requirements, or it's something that we use to check accuracy. So that's basically integrating laser scans into models in the form of point clouds. Clash detection and design development. We're every design development meeting now, with a few exceptions, basically is done in the BIM world. It's we're looking at a model instead of looking at drawings. Digital cube was mentioned there. We're using BIM in planning and collaboration. So now when we're doing a plan, along with it goes a 4D plan. And again, communication, risk management, it's a massive win for us. It really allows us to communicate the specifics of a particular job risk profile to senior people and indeed team members. To be fair to our BIM team, every challenge that we throw at them has been met on an ongoing basis. The innovation and the intelligence and the smartness of these people is not to be underestimated, and my hat's off to them all. I'm not an expert myself, but I have some knowledge, but it's very, very impressive what the people are doing, and how quickly they can do it. And one of our big points of focus at the moment is managing complex data flows, and we're probably getting to the point where we're going to start employing full-time data managers, either organizationally speaking or on a project-type basis. Our team then, Ray Coote, who's the leader of our BIM department, has won awards for his work. His thesis for his master's effectively allowed you to walk into a site in virtual reality and get inducted in it. And I suppose it's something that, was unexpected from all of us. When it landed, we decided we'd put it forward for an award, and he's won a couple of awards as a result of that, in conjunction with our safety lead, Joe Dwyer. So massive win there for us. The bid department, where did we start? We were working in 2D imagery, that kind of stuff. In regards to models, then we were initially producing them in-house, but they were provided by clients, and they are more increasingly now. I suppose what really drove the need for the integration of BIM into bidding is the market requirement, the competitive part of it, and being able to compete with our other big competitors, because we are a tier 1 contractor. 4D planning obviously is a critical part of our bid process. Every bid now, with a very, very few exceptions, would have a 4D plan being submitted as part of the offering. Logistical planning and spatial constraint planning is a key risk management tool, and indeed a financial management tool from a preliminary perspective. And it's obviously that integrates into the estimating process as well, which we'll talk about a little bit more later. BIM models and simulations are used for selling our pitches to our internal team and to our external team as well. The end user requirements drive BIM uptake in live projects. So what's happening is that, you know, we are seeing some speculative developers not looking for a BIM deliverable on jobs, and then we're seeing others that are looking for it when they get a client. So that can be challenging. Contractually speaking, you might go into a contract with no BIM deliverable, and then halfway through you might end up having a significant one. So managing that process and understanding that is an ongoing challenge, but yeah, we're up first. Designers have mostly moved to Revit for design coordination, and 2D drawings are becoming less and less prevalent. We're on a couple of jobs now where there's no 2D drawings offered at all, which is a more recent development, but it's a welcome one. In short, Collen don't BIM without BIM. That's the way we are. It's fully integrated into our processes. In regards to I suppose the estimating team, slower to take it up because their processes are primarily based on, you know, essentially an Excel sheet. But now the models are being used for takeoffs, quantity checks, where there's always concerns around using models that have specifications embedded. So we do always refer back to the specifications, but at the same time, as things improve, we expect that will change. We've migrated our estimating software from BuildSoft to Qubit due to its interoperability with the BIM platforms, and our estimators are using models for takeoffs and for estimating on an ongoing basis. Pretty much all of our projects now would have a BIM resource allocated to them. Marketing, similarly to our estimating team and our bid team, you know, our marketing team were key to take up the use of the models. So we're talking about using it to sell our projects and advertise our projects and sell ourselves. So we're looking at 4D simulations, case studies, and simulations of logistics plans been shared on social media. I'll just push on there because time's against us here. Planning absolutely is now fully integrated with the BIM process. Everything is getting a 4D plan. So the first thing we do on a bid now is get the program wrote, and then we start developing the 4D plan, and then we adjust our program afterwards. So it is an ongoing, interesting challenge, and it's working very, very well for us. And it's a massive de-risking measure for us. In regards to operations, pretty much every job now would have some kind of BIM deliverable on it. Our data center projects and airport projects tend to have a greater level, LOD 300 to 500, and normally have 4D and 5D requirements, although 5D has fallen away in the past couple of years. Our team are literate in BIM. They're able to use Navisworks, they're able to use Revit, and we successfully utilized it for quality checking of setting out, etc. In regards to IT, then IT have responded strongly to the BIM department needs. So we now have much higher levels of storage and security associated with that. I won't go too much into that. So what have we learned in summary? BIM has driven innovation. It's accelerated our digital transformation. It's improved our competitiveness. It's improved our risk management process. It's facilitated digital leadership in our business. It allows us to retain clients and procure new ones, and it's allowed us to grow technically as a business massively. It's a huge, huge win for us. So in regards to ourselves, then, you know, feel free to contact myself or anybody in CEDA if you want to get in touch with us in regards to if you're interested in working with us, if you're interested in partnering with us in supply chain, and if you're interested in working with us as a client. Thanks for your time, and that's me.
Yeah, thank you, Stephen. That was the tour de force. I know you were under a little bit of pressure, but you rose to the occasion very well. Thanks. And you have you also have an impressive story, which makes it a little bit easier. Our final speaker, Thomas Naughton, is a senior strategic product consultant with a long-term supporter of CETA, Procore technology. He will share his views on the evolution of smarter construction. Over to you, Thomas. And
Matthew. Thanks very much, Sean. First of all, it's great to be back here at CETA. Alan and team have done an amazing job, and there's been some interesting conversations beforehand. So looking forward to the Q&A at the end of the session. So yeah, jumping into my presentation today. First of all, thank you all for joining. My name is Tom Naughton. I'm a technology and construction specialist at Procore, easy way to put it. Procore, supporting the industry in communication, collaboration on a single platform. And in terms of today and what I want to discuss, we really want to just focus on technology, how it can help you gain a competitive edge, while also driving your company culture. I think it's important, and I think there's no way of getting around it. You know, talking about COVID-19 and technology, I think they're interrelated really. It's really impacted how technology can support our business moving forward, or any business moving forward. A lot of companies have looked to technology to solve their issues with this decentralized workforces working remotely. But also we'll discuss a few other challenges as we go through the presentation as well. Additionally as well, just before we dive into some of the more juicier content, I'd just like to remind you all that in this session, we may be looking at some forward-looking statements about either our products or the business. So just make sure that if you are making business or purchasing decisions, that you're focusing on what is available today in these in software solutions. And if you want to read this slide further, you can see our safe harbor statement at our website. A little bit about Procore, and for those that are aware of Procore, I just want to reiterate kind of how we operate. We view Procore and our team as an extension of your team. We measure our success on your success, and our mission is to improve everyone's life in construction. And that's key when looking at technology, when you're looking to adopt technology into your business. It needs to improve everyone's life. Challenges are faced, or you will face challenges if technology is not easy to use. For example, people simply won't use it. So that should be key. And one of the top considerations you make as you start to look at technology. Procore is a group of 2,000 plus technology, construction professionals, and advisors. And again, our only focus is on the construction industry. With that, we can really focus in and hone in on the challenges that our industry faces to support construction businesses in efficiency and productivity. Looking at the screen now, basically this is our special sauce. Construction, as I've said, is our only focus, and we solve challenges or construction issues holistically. One of the key challenges, and we can talk about it all day, is collaboration. With collaboration in mind, one of the key focus points of Procore, or the key advantages of Procore, is the unlimited user license model, which means that we can enhance and drive that collaboration. There's no user-based licenses, meaning that you can invite in every stakeholder of the project into the Procore platform to drive that collaboration. Additionally as well, we have award-winning support. We're not a vendor. We consider ourselves as a partner to our clients. And we will help you on your digitization journey. You know, we've done this before, meaning that we can really point you in the right direction based off past experiences and drive you to look ahead rather than looking at a point in time to say, you know, hey, I need to solve this challenge now, but what's coming down the line? How can you use technology 10 years ahead to gain insights into your business, make better decisions, etc. Moving back to COVID-19 and last year with the pandemic, it really put a magnifying glass on some of the common industry challenges that we face in the day-to-day, but it's also brought new challenges with it. Construction companies have tried to adjust and adapt to the new method of working, and it's forced companies to, tighten up and control what they can to ensure that their business is successful and can operate in this new world. And that's become a challenge for a lot of people. And again, a few things on the screen there that I'd like to focus on is, take consideration financials. If you don't have insights into the financial operations of your business, especially with the challenges faced last year, you could be in real trouble. And there's solutions out there like Excel, for example, that financials are typically managed in construction. How can you get insights into that information and ensure that the next level of project that you're on you can make those better decisions. So there's just some ways that kind of utilizing solution like Procore, you can support your business in tightening up and learning from the data that's inputted into a system, which we'll talk about again later on. For anyone in the infrastructure industry, it's not going to be new. This isn't going to be new to you all, but there is a large wave of work coming in the next few years globally. McKinsey says that there's nearly 4 trillion worth of global infrastructure spending due, and there's a massive gap there currently in that spending. So when we take into consideration this large amount of work coming our way, the labor shortages that we face, the material shortages that we face, how can you successfully complete projects going forward? It's going to be a massive challenge. And a lot of companies have looked at technology as a solution to that. Being able to be more competitive, to be able to work smarter, not harder. So you can gain insight into your business and really cut down on rework, for example, ensuring that your rework and waste is something that you can kind of massively reduce as these new challenges are arising for us. If we look how we managed this previously, take the Celtic Tiger, for example, the solution has always been to throw more bodies at the work. We're working to a tight timeline. We'll get another 100 people in, no problem. And that's not going to be able to be, something that we can focus on going forward. It's going to be a challenge, and we need to start thinking smarter. We need to start utilizing technology to help us and enable us to overcome these challenges in the future. So on this slide, I just want to show you that, look, construction is complex. I'm not here to tell you about that. But what is important to note is that there's multiple different stakeholders, there's multiple different moving parts. Every project is basically custom work. There's no projects, the more or less projects are not the same. And stakeholder dynamics can be challenging. Additionally, as well with COVID, as we said, companies are working decentralized. How can we solve the challenges related to social distancing, etc.? How can we make sure that we're compliant with the new guidelines set out for operating in the construction industry? So with that in mind, we want to make sure that, everyone is aware of the latest information. Everyone can collaborate together to reduce the risk of a weak link in the chain becoming an issue, impacting the program, increasing the cost of your project. And there's companies out there that may think they already have this solved, and it's going to be a challenge for you. If you think you have it solved already, it's you're already behind the curve. Construction is shifting. The way we operate is changing. So the time is now to get on board with technology to support your business and your projects in the future. One of the solutions to this, and Procore's solution to this, is to create a construction platform, one platform that you can collaborate across all project team members, be it the design team, construction team, and also then the owner or the client, from one place. This is not one single software, right? So Procore has products that stem from pre-construction to project management, quality and safety, and financials, and also resource management. However, we're also aware that there's best-in-class solutions out there for other aspects of what you need to do on a day-to-day basis. ERP solutions, analytics, for example. So Procore integrates with these best solutions. And again, one of the best pieces of advice that I can give you if you are looking to adopt technology into your business is not looking at it, as we've said earlier on, at, hey, what am I looking to solve now? But what am I going to be looking to solve in 5 years' time? How can I streamline the information between systems? How can I report on all of this information centrally and get a holistic view of your business and your projects? The next level of that is going to be how can I use that data to analyze and predict issues that may arise on the next project or a similar project that I've done previously. So the integration piece is key to a platform, and also then as we at the bottom of that kind of bed is the analytical piece, which we're going to talk about in the next few slides as well. Just want to highlight one of Ireland's, I believe, forward-thinking companies, and one of our clients or partners is Ardmach. Ardmach are probably one of the best data center fit-out companies around, and some of the things that they're doing in their business is absolutely amazing. You know, they've been evangelists of smart thinking, smart construction, lean, BIM in the industry. And just to highlight a quote there from one of my good friends, Fergus, he's highlighting that they're working smart, and that's been a key company initiative for them. And the key thing there is setting out a roadmap, understanding where they are now, where they want to get to, and bringing in the right technology to solve their solutions to get them where they need to be. So Procore is a big part of how Ardmach operate, and really, really pleased to have them as a partner here at Procore. So data insights followed by data input. Again, we're capturing all this data digitally. That data needs to be captured in a structured format so you can get insights into that data. So the input is key. Procore has functionality such as restricting or marking information as required. So at input, it needs to be required, or the key information you want to be captured is being required by the field team, by the site team, so you can then analyze. So without that standardized data input, you will not get the advantage of gaining insights into your data. So that is key. Just looking at kind of the stages of digitization and insights, the key area I want to focus on here is kind of reporting, or kind of where the industry is at now. There's still companies out there that will do ad hoc reporting, manual reporting, which is really, really heavy on admin. And, you know, that's increasing costs. It's increasing time and effort from your team members to kind of manually put together reports. The next stage of that is using a platform like Procore or technology and integrating it into solutions like Tableau or Power BI, where you can get that holistic view of your project data without having to put together static reports at a point in time. So that's going to be key to kind of help you with the challenges that we're facing in relation to shortages, rework, etc. The next level of that is going to be artificial intelligence. So rather than having to go in and understand your data, machine learning and AI will predict it for you and give you the results that you need. And finally, then, just want to highlight out on a customer that we have, which is BW, just to show you on the screen kind of what the advantages they're getting from using something like Procore Analytics. So yeah, I'll leave it there, guys. I'd like to thank you all very much for this morning, and yeah, looking forward to the Q&A.
Okay. First of all, I want to thank. Sure, I'm. Okay, sorry about that. This is not a software I'm very familiar with at this age of my life. We're going to start. There's a couple of questions. May, do you want to add anything to the answer you typed to the question that was posed to you about BIM and the adequacy of PI insurance to cover issues surrounding it?
The only thing I'd add is that it's important to remember that BIM is a process. We're still designing buildings, we're still building buildings. The only issue with insurance is if you're doing something extra, then you've informed your insurers about, and just making sure, because you're doing so much digital stuff, making sure that's insured, because that's a new element.
Thank you. There's a question here, Stephen, and sorry, I beg your pardon, Thomas Bock, and or maybe you. I'll put it to Tom Noctor as well. But the question is: will complexity increase or decrease with offsite construction and modularization?
Well, it depends. I mean, I think one of the problems is I'm not familiar with Irish construction, but in Germany, we start too fast with the construction side. The planning is not finished, and they do sometimes simultaneously planning while they're building. And so they try to finish or the project as fast as possible, but in the end, it's going to last as much longer. We have several disasters, construction sites, Berlin Airport, Elbphilharmonie in Hamburg, Stuttgart main station, and so on. And it's actually getting worse. And according to me, and also legal proceedings getting worse. What May reported, I think the numbers in Germany are much worse. And so I think it's already pretty messy and complex right now in conventional construction. So for me, since I'm in this business, this offsite manufacturing and on-site or robotics and so on, I think for me it's easier. It's less complex to plan it properly, to spend more time on planning, to prefabricate as much as possible, then assemble it in an orderly, safe way by robots on site. Then you have no rework because the quality is right at the first time. And actually, you will not have any legal proceedings because the robots can't screw it up unless you program them wrong way. So I think it's win-win. It becomes less complex. It seems complex in the beginning, but what I experienced in these in the last decades, what I showed you, for me, it's less complex, and I don't want to go back to conventional construction. So I'm trying to push this off-site manufacturing, on-site robotics, and so on. For me, personally, for my experience, it's less complex.
Do you, Stephen or Tom, you're both involved in data centers here in Ireland, of which, just for the benefit of Thomas Bock and May, there has been a huge proliferation of data centers here. They've provided great opportunities, I think, for the companies that are presenting here to hone their skills in using digital technology. Would either of you like to comment?
I'll jump in quickly if that's okay.
Sure, Stephen.
Yeah, I guess, I mean, I'd agree with what Thomas said there, that it's definitely more efficient. It involves a lot of upfront planning, and there's always going to be the first couple of projects where, you know, you learn a lot and the lessons learned part kind of becomes more prevalent. That risk goes away the more you do it. There's a cost premium for it. But with these jobs that we're talking about here in the data center world, they'll bear those kind of premiums to de-risk delivery, you know. So I think it's definitely the way it's going. You know, depending on the client's requirements and their budget and, you know, their end users, we're seeing modularization of you know, electrical switch rooms and transformers and other bits and pieces within data halls. We're even seeing with racks as well, and it's definitely you know, it reduces on-site complexity, but there's obviously upfront planning complexity. That's what we're seeing, you know.
Sure.
Yeah, I'd like to add something there as well. I totally agree with what the guys have said there in terms of reducing on-site complexity, but it does add other complexities as well, like as Stephen mentioned, planning, but also logistically as well. You know, having to manufacture off-site, but actually get it to site and then integrate it into a building or a project adds other complexities. So while upfront, yes, there is other things that need to be considered as you start on your offsite journey as well.
Sure. Matthew, do you have any comment you want to make on that?
Yeah, well, I suppose from our point of view, we're on a number of projects with you know, modular construction happening at the moment. You know, particularly precast walls, precast floors. You're then into pod situations, you know, for your bathrooms. So they will be the main areas where we're seeing, I suppose, modular construction happening off-site, coming to us. So I think those two areas for us, we're seeing the benefits. You know, a couple of our projects are very large, so it's easy to get the product to site, you know, being able to store it on site and then place it when needed. So we're seeing huge benefits in that. I mean, we're working across Ireland and the UK in terms of large commercial, residential, hotel projects, and particularly on the hotel side, you know, you would see a lot of the modular stuff go into place. But from a Procore point of view, for us, it's a huge benefit for us on that side as well. You know, huge collaboration there. I know Tom mentioned a couple of statements there. Procore, they see it as part of the team. We would very much see that. We're probably into a 3-year journey with Procore, and it would be hard to see life without it. Simply from a collaboration point of view, you know, when we're getting into areas like using I suppose the partners with Procore in terms of Power BI, we use an online induction system, we use Evercam. So all these systems are feeding into Procore,
sure,
and feeding into our daily lives here.
Okay, thank you, Matthew. Thomas, since we actually have you here, the challenge we face in Ireland here at the moment is we need to double the output of residential units. Now, we don't have, I mean, you know, that your examples from Japan are very impressive. And I mean, it's absolutely amazing in Japan what the frontage they need to form a high-rise building. I mean, it's you wonder where the stairs fits in it all. But we don't have that challenge here. Now, if you look at that kind of environment, what do you think the first steps towards more robotization on site would be here?
Well, I don't know much about Ireland, but I've been around in Britain quite a lot, and
very similar.
Very similar. But the market is how many % of the British market? I'm not sure. How big is how many units do you build normally, conventionally in Ireland? Housing units or apartment units? I'm not sure.
Well, it probably would be about 15,000 a year.
15, and you have to double it. You have to do, yes, 30,000. This is quite nice number, and I think if you would focus on let's say two companies or 2 factories, and you don't, it doesn't fit to use the Japanese experience, but something would fit that you have some subsystems produced. Or maybe you do let's say 2 big companies that make 15,000 units, like the Japanese do it in prefabrication, like I showed you the slide, or you break it down to, let's say 10 factories that focus on subsystems, and then these would supply the subsystems of the residences to the construction site, but you need a very good interface control of the tolerances of the subsystems so they fit at the final on-site assembly. And then these small companies, let's say you would have 10 companies all over Ireland doing 3,000, 1,500 to 3,000 or more components of subsystems, and not the whole house by itself. And then they could maybe survive in the end once the demand is over. And because if you do it now on a big scale, and then later you have a decreasing demand, they might go bankrupt and run out of business. So maybe it's better to have subsystem production decentralized in, let's say, 10 or some factories, and then you can survive later, and then you can go on. And I don't know what's the major material. I've seen some steel. You doing a lot in steel, or is it also bricks like in Britain?
It would be very similar to Britain, and use of steel in housing in apartment blocks, yes, but in residential housing, it's not very common. Thomas.
So it's bricks like the little bricks like in Britain, or?
Yes.
Then you can, I did once for the Danish, they also used the little bricks. For the Danish, I did a prefabrication robot for brick walls for Denmark. And this is already possible to do it in a controlled environment. And the tolerance can be controlled by some kind of steel components because they have a higher precision. And then you could do the final assembly of these decentralized produced brick walls or elements on site, and using some steel components to get the precision for the final assembly. And I also did in Germany some prefabricated brick walls, robotics for prefabrication of brick walls. We did even the floors. We did the floors in brick, but it contained more concrete, like 15% concrete. And then even the roof. I mean, it depends how far you want to go.
Sure.
So
sure.
I think it's possible.
I think it sounds to me, Thomas, that it's a subject that we should actually perhaps see if we could maybe later next year get you to speak on with a little bit more, if we gave you a little bit more knowledge of what the market is, just to get your obviously world-class experience. I have two other questions here. Matthew, there's somebody asking, would you like to share any stories of active technology platform implementation on the projects that you mentioned?
Yeah, so I suppose going back to a point that Tom made in his presentation around COVID, you know, when COVID hit, we do a lot of work for the health service executive here in Ireland, which is looking after the hospitals and all that. So I suppose when COVID hit, we had the systems in place. We had Procore, we had our online induction, we were using Zoom through Procore, Evercam. So we had all these systems in place. So I suppose that just gave us the edge. We were able to hit the ground running, not to have too many people on site. We were able to collaborate with design teams and our clients, you know, remotely sharing the information. So that really gave us an edge there. Currently, I'm sitting on a project in Dublin at the moment. It's a 60 million euro residential project, 250 apartments. The client wanted us to use a different system, but when we showed them Procore and showed them the ease of use, and primarily the ease of use out on site, and that's where we see the main benefit of Procore. You know, the guys are able to see updated drawings on their iPads out on site. You know, they're not having to run back to the office. They're able to request, you know, for information. They're able to do all of their day-to-day stuff out on site, or safety or quality inspections. So the real power, you know, from Procore is out on site, and its ease of use out on site.
Thank you. Stephen, I have one question just to ask for you myself. This is really from my own knowledge. In actual fact, as you go and try and bid on a project, how digitized is the supply chain above you in the system? In other words, your own sub-suppliers, subcontractors, you know.
Yeah. There's quite a high level of, I suppose, what you might call digital literacy, you know, in the industry. So what we're seeing is a lot of our larger supply chain partners on the big projects, the data center ones, came on the journey with us and, you know, developed their BIM processes and their BIM capability in conjunction with ourselves. In fact, the MEP side of it, I'd say we're always slightly ahead because they were always applying to be, because it suited their model better than perhaps it would have done with the CSA work. In regards to the smaller supply chain, there's a lot of them are coming up to standard, but there's quite a lot of them, you know, that are kind of exclude themselves from access to these larger projects because they're not digitally literate. But what we're doing is we're kind of sponsoring good quality suppliers and assisting them, you know, either with our own team or the design team that we're working with to deliver, to help us bid, you know, techniques. So for example, you know, if a guy doing a joinery, you know, like a receptionist didn't have 3D capability, we might transfer the drawings to 2D for him. And then, you know, the next time around, we might say, look, we'll get it drawn up for you. And, you know, maybe the next page you come along with us and then you get it done yourself, you know. Yeah.
Thank you. May I have, yes, could I put a difficult question to you that is coming in? Has she? Okay. Well, maybe I could put it to one of the others, perhaps Tom or Stephen. The question is, would it be fair to say that BIM does not work on a traditionally procured firm price contract?
Stephen, any insight into that? Wouldn't have too much.
Sorry, give me that question again. I'm very sorry, I missed it.
Yes.
Apologies. Yeah.
Would it be fair to say that BIM does not work on a traditionally procured firm price contract?
No, not at all.
I would agree with you.
Yeah, that's not a factor at all. It's all about how you deal with it in terms and conditions, you know. Sure. Yeah. Okay. Not at all. Yeah.
Okay, I think at this stage it's time to bring the gavel down on proceedings, and I just want to thank all of you. Thomas May, who has departed, Stephen, Tom, and Matthew. I just wish we had had more time to develop some of these themes, because I know we're sitting with people who have a huge amount of experience, practical experience of digitization. So with that, we'll call it a day. Thank you.
Thanks, everyone.
Thank you.
Thanks, guys.